So I'll tell us a couple of stories about Rich. I first met Rich at the JVM Language Summit. I was the first one, maybe. And I was already working on the book, but we hadn't met. And I had corresponded with him and had corresponded with many of you in the room who were on the Clojure mailing list back in those days. And I met him at the summit, and he came up and introduced himself and said, it's really exciting that you're working on the book. And he gave me a Clojure pin. So he pinned me. I called my wife that night, and I was like, wow, I finally met Rich. He's a really nice guy. And he gave me this pin, and she was like, what? I mean, given things you've already heard me say, she has, reasons to worry about my behavior, when traveling at conferences and so forth. So since then, I have had about the most pleasure you can possibly have writing software in the industry, increasingly getting to work with Rich on a day-to-day basis, violating all kinds of sacred principles. We have these agile stand-ups in the morning that are supposed to last for 15 minutes, and sometimes we'll look up and he's, I've been talking about something for 2.5 hours, and I'm thinking, don't you guys all wish that you could be doing this? It is absolutely a pleasure and an honor, and I just want to get this started right. I'd like to ask everybody to stand up and applaud before we start this for Rich and the work he's done to create Clojure.
Thank you very much. Is this working? Can everybody hear me okay? No. How about now? Oh, no. See, you told me I had to button my shirt, and I said, it's going to be so hot. How about now? Okay. Before I get started, I think some of you may have been aware we had a little interaction on the mailing list last week about dates and whatever, and I replied harshly to Chaz Emmerich. And while I'm very sensitive about the fact that interactions on the dev list be constructive, the way I replied to him was definitely not. So I just wanted to apologize. Chaz, I'm sorry. So that's certainly not the example I want to set, and so I had a bad day. All right. So is everybody having their mind blown? Oh, that's print, isn't it? So somebody was talking about not being able to use computers. That's my specialty. Yeah, I'm having my mind blown too, and I kind of expected that. The thing I didn't expect, which is kind of sad, it's already been tweeted about, is that Ambrose has better hair. Okay, so we have had some really intense topics today, and I'm going to talk about something substantially less sophisticated than a lot of the things you've seen, and that's Clojure itself. And in particular, just kind of survey areas I think would be interesting for Clojures. Many of them that have been talked about before, and what I want to do is sort of survey them and get some of the ideas on the table, but leave a lot of time for interaction and talking, especially with anyone who possibly might want to do some of this stuff. However, I do want to say this is not a roadmap. I have more ideas than I have time, and I would definitely need help. Also, a lot of these things are half-baked. I don't know if anybody can read that. That's a half-baked guitar pedal, which is pretty cool. But most of these things need more design time and effort before they even get any kind of implementation time. So what would we be interested in for core? One thing definitely is leaner. We've heard this several times already. There's a bunch of targets for Clojure that would like to see faster startup times, less memory usage, and things like that. And I think fundamentally we face a tension with a language like Clojure and any Lisp between the interactive development experience, which we prize, and the production usage, where only some of the same tools that are required during development are also required. And I think that some of the areas are kind of clean cut. People understand Android. Somebody mentioned startup times on App Engine. Other things I've personally found to be challenging is delivering Clojure-based code as libraries to non-Clojure applications. So I wasn't expecting to get any Clojure overhead, and now I have either some impact on my startup time or in memory usage or something else. That puts a lot of pressure on Clojure to deliver something in a jar that's very minimal. And while I say that's a tension with Lisps, everybody should be aware that Lisps traditionally have had very good tools for tree shaking, dumping out the evaluator, dumping out the compiler, and things like that. That's not like sacrilege or anything. Most production Lisps have had these facilities for decades. So I think it would be worth targeting them. Concretely, I think there's a couple of things, one of which is just the notion of moving ASM out. Currently, it's bundled in. And interestingly, other than in the REPL environment, we don't, right now, do any dynamic compilation. Because none of Clojure's constructs require compiling code at runtime. Unless your program calls eval, no Clojure constructs require that. Now, it was interesting in David's talk how he mentioned the fact that that might actually be interesting. For instance, if we wanted to have logic programs be extensible at runtime, you would need some compilation then as well. But I think that's also sort of similar to the REPL. The idea of adding rules to a running system is something that might be rare, or at least something you might want to have a knob on. So the thing about having knobs or stripping out metadata or a lot of these other concepts goes down to something that's sort of fundamental, which is we need multiple build targets. Right now we have one. We build Clojure. We get this one thing. We've decided what's going to be in it. It includes metadata and all kinds of support for development. And I think we do need the notion of a development-less build for production deployment, even if, as Daniel said, it's interesting and useful to have an interactive development on something like Android. It's also interesting that when you're done with that interaction, you yank it out before you give it to your users. So the shaking of metadata there, but I think the flip side of saying we need to start investigating multiple deployment targets is that we can go the other way as well. We can say, you know what, there's a bunch of things we sort of said, I don't know if we really want to incur the runtime overhead of that, so no. Where we could say yes. We could say let's build debug builds or developer builds with even more stuff. Attach the source code to every function, have it explain to you why your macro call wasn't the best thing ever, or various stuff like that. So I think overall, pursuing leaner can have benefits that actually want things to be less lean. But it's definitely an important area for Clojure. Another area that's interesting is unifying things with ClojureScript. We had a couple of objectives in building ClojureScript, one of which was don't change Clojure. And we did that. The other was not to try to take on and solve all the problems of making code work on both. The main thing I wanted to do was make the language be present and be the same language. And that we did. Okay? ClojureScript is Clojure on a new host. There are all kinds of still open questions about how can I write a set of library code that's not very host dependent once and use the same source and use it for Clojure apps and use it for ClojureScript apps. Even more interesting are some of the concepts of being able to say, I'd actually like a knob that says how much of my code do I want to run on the server and how much do I want to run on the browser. I think is very interesting. So that's an open area we can explore. That now, I think, looking at what kind of support is required to write libraries where we can share the source code. Everyone should remember it's always been a non-objective of Clojure, as Stu said, I think, in his talk, to support taking an entire application and moving it from any of the hosts to any of the other hosts. Right? That always involves an amazing layering of re-abstracting of host stuff, loss everywhere you turn, and it doesn't give you anything. If you run the exact same app on .NET or on the JVM, it doesn't really feel any different. And if you were trying to extend that to ClojureScript, you'd really fall over inability to talk to the disk or over the wire and stuff like that. So we're just talking about libraries like CoreLogic and things like that that are more algorithmic or data-driven that would port. We'd like to write them once. A conditional compilation is certainly the leading candidate for giving us some of the knobs we need to say where we do in the very few instances. If it's ClojureScript, do this. If it's JVM, do that. And I think the CLR port has always wanted this ability to switch things around. That's the current candidate. I'm still interested in other ideas. If you say, wow, I knew that from Common Lisp days and that sucked, I have a better idea, now's the time to start talking about it. The other thing I think we can get flowing back from ClojureScript effort is getting some of the analysis results back from the ClojureScript compiler. It was certainly part of the design of the ClojureScript compiler that I fixed the errors of my ways in the Clojure compiler, which I don't think were many, but certainly in one area they were, which was that it produces this tree of Java stuff, and it uses dynamic variables, the Java equivalent, quite extensively, yielding an AST that's kind of fragile. And the ClojureScript AST, which you saw, I guess Chowser may have shown it to you, right? While it seems verbose, actually is not. Those are all persistent data structures. You're mostly seeing multiple generations of the same structure that occurred during the nesting. So it looks like a lot for a human, but it's nothing for a machine. And those are all stable, persistent data structures built in a nice way. Tools have been desperate for that output. Now, of course, the amount of analysis that the ClojureScript compiler has to do is pretty low. It doesn't have to deal with types and a lot of the other stuff that the Java side does. But it's an open question, right? We can take the current analyzer, which again Chowser has done work to expose as data structures, and try to expose that output as data structures more similar to the ClojureScript output. So we can start saying, okay, this is a format we can start using for tools in both places. Or we could try to enhance the ClojureScript analysis phase to do some more of the work that the Clojure one does, so it can do more of that job of tracking types and things like that. So Clojure and Clojure is like the pot of gold, or the carrot or something. It's always somewhere in the future. But I do think we've taken on a bunch of things that really substantially move us towards being able to do this. And the one that we saw in ClojureScript quite delightfully was the fact that protocols, records, and def type ported swimmingly to JavaScript. Those concepts, the effort put into making sure they weren't tainted by Java-isms and Java semantics that I either didn't like or didn't want, paid off because we did not have to recreate those semantics on JavaScript. The flip side was, and the difference in the ClojureScript compiler, for people that haven't dug down, is in the Clojure compiler currently, the protocols is a set of macros. And so the protocols actually require a substantial portion of Clojure to be alive before protocols work. In other words, they're not at the bottom. They're not a compiler feature. They're not a primitive feature the way def type is in both places. In ClojureScript, I made the compiler be able to deal with protocols at the bottom. So at the bottom of ClojureScript, we have def type and protocols working. Like I delivered to the guys who started to work on the library a blank core.clj where def type and def protocol and extend type already worked because there were compilation features. What we found from having had that is that the promise of being able to build up the data types and abstractions and the function and the library on top of the abstractions from scratch on types and protocols is definitely there. All the abstractions, as Chowser showed you, are protocols. It was a complete pleasure to develop them. I mean, things that somebody showed the set of interfaces. It was like 40, 50 interfaces. That's 40 or 50 Java files. It's about this much ClojureScript. All the abstractions, just def protocol, def protocol, def protocol, def protocol, right in a row in a single file and maybe 100 lines. You're done with Clojure's abstraction set. And then you can implement it per type with def type. That's completely great. And the lesson from that, as we want to move forward with Clojure and Clojure, is that we need to move protocols down. We need to make protocols a compiler thing. And the open question there is, do we want to modify the Java compiler one more time, one last time, to move protocols down, or do we want to try, when we take on Clojure and Clojure, to start with the Clojure script compiler and build it up with the knowledge of the Clojure compiler? And that would require sort of a little bit of refactoring of, I hate that word, changing or something other than refactoring of the Clojure script compiler to make it more amenable to having different output targets. Somebody was talking to me in the hall about Objective-C, and the Clojure script compiler is tiny. It's like 500 lines or something. It's really easy to play with, and the emitting part of it is only half of it. So making new emitters should be relatively easy. And in fact, making an emitter that emitted Java would be a good first playground. Another open area, there was some conversation about this recently, is Invoke Dynamic. That was released in Java 7. And I think there's a bunch of confusion about what it is and what it can do for us, and I just wanted to try to clarify that. What it is a way to get call sites, which is sort of a fundamental construct for polymorphism, without runtime code generation or generation of classes at all. In other words, the fundamental construct on the JVM for code prior to Invoke Dynamic was the class. The class is a pretty big thing with a lot of stuff. You saw the header and the constant pool and all of this. And I guess, well, I don't feel the work is done, that they're done optimizing classes. You could make classes a lot more efficient than you have, but there are definitely backwards compatibility issues. But all the languages that sit on top of the JVM really work in user space, and all we have is class generation to sort of implement our constructs. And what Invoke Dynamic does is it adds a lower level tool in method handles for talking about code. And in addition, it sort of introduces this whole set of very functional set of tools for building the constructs you need to do dispatch without emitting any bytecode at all. So you have no bytecode you need to emit, no classes that you need to emit. And that facility is coupled with another sort of critical facility, which is, it seems largely invisible to anyone who uses Java, but if you think through what Java has to do, you realize there must be some magic somewhere, right? Because you have this really fast, inlineable virtual dispatch system, and you have the ability to load code dynamically. So if you've inlined some dispatch based around knowledge of the hierarchy, class hierarchy, then you load a new class. How do you get that to work? It would seem as if you'd have to stop the world and update things that were not declared volatile and not mess up anybody's view from any threads. That would be really cool to have. And in fact, the authors of Java have it. It's called a safe point, and it's used internally as an implementation detail of the way class loading works. And so the other thing Invoke Dynamic delivers is a kind of access to that. The access is not the way I would have preferred, which is sort of explicit direct access just to that feature. The access is sort of tied into the call site system, but it's still there. And so the combination of these things gives us a set of tools we can use to mostly optimize Clojure, because we had to build all of our languages without this. So from a semantic standpoint, we pretty much already decided on semantics based upon what we could do with classes. So it's not as if an existing language could do something radically different semantically without breakage by adopting this. A new language could, though. A new language could say, well, I'm going to make method handles first-class parts of my language, and you can pass around these pointers to methods, which we can't do without adding new semantics to the language. But from an optimization standpoint, there's a bunch of places where this could be used. One is in protocols, and keywords are perfect examples of where we do polymorphic call site dispatch. You have an entry point for a protocol. It says call this, and it frequently will see or always will see the same type coming through. That's exactly the use case for which this stuff was built. Similarly, we have keyword call sites in Clojure, which most people don't really realize, but in order to make keyword access fast, we have little call sites that say, if I'm using a keyword on a record type, and I see that type all the time, I'll presume that's the type and have a more efficient dispatch, and then only do something different if I see something new come through. Right now, we have a tension with vars between the dynamism of vars and inlining, because a var is both an indirection and a volatile. I think I've seen great difficulty on the part of Hotspot to inline through them. And so we've played with static and not and dynamic as an explicit thing. All those things are sort of fighting the fact that we don't have the same kind of, when you change your code, because it's the only time we need it, right? When you change your code in the REPL, we'd like something that we didn't declare volatile to magically be swapped in and not mess anybody up. And that's effectively what happens with class loading, but we can't do that in vars in user space. With Invoke Dynamic, we could make those things into call sites, presumably. It's still an open question to me as to how much overhead there would be, because right now we're just doing a dereference, so at least there'll be these shims for Invoke Dynamic around those. But I'm told that can all be made to disappear. And finally, you can use it, and this might actually reflect more up into the surface. You can use Invoke Dynamic to basically say, you never need to tell me type hints. You just say whatever you want to say, and we'll figure out what the types are at runtime and use Invoke Dynamic to build little typed call sites that correspond to the methods that we found during a one-time only reflection over what came in. And so it's not like it's reflection fleet, it's just reflection once. And you say, oh, what did I get, and what do I need, and let me build a little call site, and then as long as I keep getting the same type through here, I don't need to do any of that work. Because I didn't have that, and because we have metadata, we already built a system for declaring types, and we have local inference, and so you can get a lot of this benefit for almost no effort by just declaring one type here or there, and then after that we can track method calls and everything else. So it's not like we're in deep need of this, but it would be nice to have this be the backup for when you didn't say that, so that you didn't have the reflection warning or worry. Why is this 20 times slower for some reason? So I made a mistake here. The trade-offs, however, with Invoke Dynamic are performance, right? Until the performance of this is as good as the existing methods, we get nothing from doing this. The other trade-off here is it's a Java 7 and up only kind of feature. So we can't move to this. We'd have to do this in addition to what we're already doing. But that's not insurmountable. I think as we start to see the newer builds of 7 bring the performance of Invoke Dynamic to parity with virtual method dispatch, it would be an interesting thing to start looking at. And we're interested in having people do that. Certainly one of the things is getting ASM out, because once we get ASM out, we desperately need to upgrade it. We're using an ancient version of ASM, and the newest versions have support for this. So these things tie together. Leveraging logic. So we saw some just terrific presentations. I'm going to talk about a very minor application of logic here, but anyone that saw Dan's talk should be thinking about rewriting Clojure as a logic program and running it backwards and finding startup ideas. The stuff we saw yesterday was completely amazing. But more modestly, one of the things we saw, and we saw it this morning, right, is moving from pattern matching to predicate dispatch. The other thing we often talk about in the context of using core logic with Clojure itself as part of like a language thing is doing type checking with it, or some variant of it. I think we have an amazing facility in metadata for communicating about our programs in a way that the compiler doesn't even need to understand, but to the extent we can capture metadata, capture it in the analysis phase, propagate it to an external tool, take the results of analysis, and pass it to something like core.logic. I would expect people to do things like what type checking does, but also much more interesting things, really to think about programs as being queryable entities, and to be able to apply anything you want in metadata and then ask questions that sort of cross the boundaries of what is typically possible with type systems. So I'm very excited about that. And then David already laid out how predicate dispatch might work out. And I think he identified sort of, so I don't like pattern matching, is a simple sentence to say. But the thing I don't like about pattern matching, two things, are that it's closed, right, instead of open, and that it's order complected. And so those characteristics of predicate dispatch being open and order independent, I think are really, really strong. In addition, just the kinds of things you'll be able to talk about for dispatch are categorically different with logic than they are with pattern matching. Pattern matching is this little structural thing. It's really branching in the realm of the programmer's decisions. Right? If you had predicate dispatch and a logic system, you could be doing branching in the realm of the business person's decision process. And you'd be able to show them the logic part of the program and say, is this what you meant? And they'll be able to say, sure. If you show them a pattern match and say, is this what you meant? What are they going to say? Did you just tell me to? Right? That's what they're going to say. So I think this stuff is completely awesome. I'd love to see people, help out David and Ambrose and in taking what they've made and applying it, giving them feedback from using it, so they can work on the underpinnings, and because there's so many areas where you can apply logic, and it really does lift your program up a whole level towards being more declarative. So this is a fantastic addition to Clojure. Okay, parallelism. Certainly Clojure was designed with a bunch of primitives based around making concurrency sane. And by concurrency, I mean you have multiple things to do, and those things might have interactions. Parallelism is you have one thing to do, and you'd like to break it up into multiple threads and do it more quickly by having broken it up. We had support for the fork join framework in the early versions. That's been horribly broken by the changes to the fork join framework and trying to deliver it in 7. We need to drag this stuff back out and revisit it. In particular, some of the things like parallel array are gone, and the way fork join works has pretty much been completely revamped. But the core concepts are still there. However, I think that we need to be careful to assess how well fork join works for certain kinds of problems. In particular, I had asked during one of the talks, because fork join is oriented and optimized for, and is really only completely safe for I/O-free, computational loads. If you were to try to have a language feature like futures, if you want to say, I want to make futures fork join based, so people could casually use something like futures and have them all participate in a fork join task tree, I think that would be wonderful. But then you have to really consider whether or not the fork join framework as delivered is a good way to do that. For instance, the answer to my question when I asked about combining I/O loads was, oh no, we carefully architected our system so that the I/O happens here and it feeds something, and then independently there's this set of stuff that does the compute load using fork join. Now, any one system can be very cognizant about that separation of concerns and partition those two things. But a construct that you want to reuse all the time can't do that very well. In addition, fork join for I/O is pretty good as long as your I/O counts are not that high. Having threads waiting for blocking I/O is not a catastrophe. I mean, people presume, everybody's like, I need to make a web server that like 1 million people can connect to at the same time, as if that's the only possible use of threads, and therefore threads are useless. But it's not the case. There are systems that do a ton of work with dozens or hundreds of pending I/Os where parking threads on them would be zero problem. And using fork join style logic, not actually the fork join implementation that we got, but fork join style logic is a great way to do that. Because it gets to my next point, which is the ideal application of fork join is when the branching points lead to varying amounts of work. Okay? If you had this big block of stuff to do, and you need to do the exact same thing on everything in this block, fork join is an anti-pattern. You don't want a fork join. You want to divide it up into 4 pieces, give the 4 pieces to 4 threads, if that's the number of CPUs, and crank through that. You do not want to build an entire tree and a stack of pending things, because you're not going to get any benefit. You've just added work stealing overhead to something that was relatively straightforward. So when you have a balanced compute model, again, this question mark comes with fork join. On the flip side, we've got fork join, and it's awesome. So I just think we need to think about how we can build general constructs that can leverage it without sort of creating things that people are going to trip over. And then the other side of it is making more parallel algorithms. We had parallel map and parallel reduce. We've had them for a long time. We want to move them to the newest model. But we have to understand that, and of course, being a functional language, we do want to keep parallel algorithms out of the collections. And we saw some Scala stuff where they combined it, and there are some cases where that's kind of easy. But we don't attach our functions to our data. We apply our functions to our data. However, we do need data that has a shape that's amenable to parallelism, and lists and sequences are not. So the stuff that we saw presented, that kind of collection, is completely awesome for parallel work, whether you use fork join or not. The vectors have a good shape for that. We do need something that could replace sequences for that purpose that has a better shape. So much more work can be done there. Data structures that are amenable to parallel usage and more parallel algorithms, I think, would be really, really great. All right, I'm going to talk more in depth about a couple of things. The first is transients and a little bit about pods. Everyone wanted me to talk about pods last year. I didn't have time. So I'm going to talk about that now, especially because I got to a certain point in this thinking and I got busy. And so maybe by explaining it up to this point, somebody else can keep thinking. Again, we had somebody talked about, I shouldn't say somebody. I'll blank out his name. We saw data structures that you could access from multiple threads and then create snapshots of, which should have reminded everybody of our transients, right? We have transients and have for a while, where we can take something that's a value, turn it into a transient, sort of update it in an efficient way, and then produce a value later. And we've had them for a while. They're alpha still. And my conclusion about them after using them for a while is that they do too much. They combine this symbiosis with persistence, right? Being able to go from persistent to transient and edit in place, which is great, and then going back, which is really a data structure kind of job, with the policy job of ensuring that you only do that from one thread. And we want to take those two things apart. We want to separate the policy from the data job. But the other thing about transients is they do too little, in that the promise of transients, while enforced, it only comes true when you use them in a serial fashion, right? That everybody, you say about them, they're not mash in place. That you actually do have to take the return value of a transient operation and use that for the next operation. It's very clean to do that if you just follow the recipe, which is write it functionally, then change it to transient, and the same shaped function will work. But you have to do that. And when people take transients right off the shelf, they often try to bash them in place, and then bad things happen when the type changes between two operations, which we should be free to do, and all of a sudden they're going to be surprised. So the first idea is to provide some construct to make sure that there's no user, the user doesn't have to be burdened with thinking about what they're doing. So there's one way, I think people have seen the diagrams of the epical time model, whatever, and there's a way to look at the use of transients similarly, right? Which is you start with the value, there's this process of making a transient from the value, and we know our transients can do that in constant time. So you can have a value without disturbing it or any of its observers. You can make a transient version, and it's essentially free. And then the operations on transients, I'll call procs for now. A proc is a function of a transient to a transient. And you can apply these procs, iteratively to produce new versions of the transient. And whenever you're done, you can take the transient and convert it back to a value. And we want to make sure that there's only visibility to the values. Right? And right now, we do that by having the transients not implement the value accessing methods. But again, the transients are sort of doing these two jobs. If you look at this, there's this nice little box around this. And that box is policy. Right? The box says, I want a value at one end, I want to give you a value at the other end, and I want to be in control of the application of these procs. So what about those procs? I mean, if you try to think more about the use of transients as a calculation model, you might want to say, wow, is this just the bad side effect stuff again? And the answer is no, right? They might modify their arguments, but they are really functions of transient to transient, right? They're not. Look, this slide pops in one piece at a time. That's amazing. They can affect the world, and they can't be affected by the world. I'm going to do all this because I don't like popping up. As long as there's some policy enforcing thing in place, it will ensure that they can only be used where the transient itself can't leak. Right? So if you think about that, if you think of a proc as a function of transient to transient, the fact that it may modify the incoming transient doesn't matter, right? Because the transients can't leak. And it's really a function in producing a new transient. And you have to use that new transient for your next operation. If you're doing something like this, that's ensured. Just like the functional transformations in any of the reference types is ensured to be an atomic serialization of activity. So if you had atomic serialization of activity that involved procs, it would be safe. And in fact, that recipe or that property means that you could always turn that kind of use of procs and transients into a function, right? Because if you put a function from value to transient at the front end, and you put a function of transient to value at the opposite end, and you do all the proc stuff in between, what does that entire thing look like to the outside world? It looks like a pure function by all definitions, because it is one. Right? And everybody knows that, but it's very difficult for a lot of functional languages to accommodate that. Right? A function only guarantees that what you send in isn't impacted by what happens inside, and what you get out is always the same if what you put in is always the same. You can meet all those guarantees and use transients or mutation inside. The trick is, can we provide a construct that makes that work safe and easy to get correct? So the idea for doing this is something I call pods, mostly because this picture is just so awesome, as is the movie. So pods do this job, right? They split the policy out from the data structure. And in fact, we have a new policy now. The policy is just value in, value out. And the pod is in control of the process. So before with transients, the data structure, because it's always wrong, right? If your data structure does the job, it's wrong. Right? This is the easy way to do design. If your data structure makes decisions, it's wrong. So now we have the policy separated. It's value in, value out. The process goes through the pod. So now the pod is the process thing, right? And as long as it makes sure that it's a coherent process to apply a proc to the transient and get a new transient, then that whole thing will work. And the beautiful thing is that now that you've got the policy separated out, you can make independent decisions. Like, you don't have to bake in the single-threaded access policy. You could have a different policy that said multi-threaded access is fine, and it will internally use a mutex to make that work, which is definitely a useful thing. So pods obviously can work with transients, right? All they're doing is taking the policy out and putting it into the pod, right? You can take a persistent map and put it in. It will be turned into a transient. You can apply procs inside and eventually get a persistent map out. But the cool thing about procs is, while that's a really efficient way to implement the proc, and that's really great, the system and the guarantees of procs will apply even if you weren't using transients. Right? Not using transients is a performance cost, but it doesn't cost otherwise. It's not a semantic difference. Right? We already said the overall use of a proc is functional at either end. So imagine if you just had a recipe that says, you must give me something immutable and a way to turn that into something mutable that the procs can apply to. And you must give me another recipe to take that mutable thing and create a value out the other side, you can make a pod around that will make it safe to use. For instance, you can make it safe to take strings, turn them into string builders, append a bunch of stuff to them, and get a string result without any potential for clashes, or even safely across multiple threads without the goofiness of trying to get a synchronized data structure, as if there was such a thing. So that's really cool, because that means that we have the first construct that could apply to ordinary Java stuff. It could let Java stuff play our game. So this is what pods would look like. I can't actually read this. You basically wrap a pod around, well, this is what this version did. You wrap a pod around a persistent data structure, and it uses protocols to decide how to turn that persistent data structure into something that can be used inside the pod. Then you send procs into the pod. So here we're sending the transient operation conj bang into the pod to modify the transient that's inside it. And when you're done, you deref it and you get a value out. And the value creation coming in, I mean, this pod could have been created with a giant data structure, and coming out, those are both constant time operations. Then this is an extensible system in that you can say, well, nobody knew about pods when they wrote string, but I can make strings play the pod game by saying the way to get a transient out of a string is to return a string builder. And a way to get a value out of its string builder is to call toString on it. And then you can make things like string cat using pods, where you reduce with append with a pod around the thing. This doesn't seem that interesting, but it actually is still better than the loop and a lot safer. And you can start building things that allow multiple processes and functions to operate upon pods. Remember, the policy is separate now. So if we wanted to have a mutex-based policy, we could, which means we could allow multiple threads to participate in the modification of an ordinary Java structure that has no friggin' idea this is going on. Or to transients, because we separated the policy. So multi-threaded access, we can do a tremendous amount with pods, right? Admittedly, a multi-threaded pod would probably use a mutex, right? Which is like, oh, there's locks. But the thing is, it can do a lot of work. For instance, it can ensure lock acquisition order, the number one bugbear of doing locks yourself. What it can't do is it can't fix the lock composition problem. Right? The lock composition problem says, I wrote some code that uses locks over here, another code here, I want to put this inside that. Now, it ends up that when you think about the way trans and pods would work, you wouldn't really put nested work inside that would be in conflict. But the beautiful thing is, should you have done that, you can make a version of pods, and the prototype version does this. It can detect that you've done that. Right? So it can't solve the problem. It can't make things magically composable, but it can say, you did something that's not composable, and therefore, I'm not going to let it happen. The other thing about pods is they give you this interesting algebra of values to copies. So for instance, clone is just this terrible thing in Java. It's almost useless. You don't know when you can use it. You don't know when it's safe. You don't know that while you're calling clone, somebody isn't totally messing with the thing you're trying to clone. It's just not a sound idea. And there's a whole bunch of things that you can't clone. But if you can imagine, if you had rules for saying, I can take your thing and I can make a value out of it, and I can take your thing and make something that can go into a pod, and I can take what's in the pod and make a value coming out the other side. You can actually write clone just like this second to last line here. Just deref podding something, and you've cloned it no matter what it is, as long as it satisfies those two protocols on the previous slide. That's kind of cool. Like, I'd like to be able to clone iterators. Of course, the things you're manipulating have to be inside pods. And then you can peek at pods. I don't think this is a good idea. I mean, I tried it, but I think, well, we'll see soon. So there are a bunch of questions around pods. This is definitely unfinished work. One of the questions is that pair of protocols the right thing? I mean, should we bake into pods or bake into protocols the recipes for getting from values to transients? So should we make that sort of a pluggable characteristic? Should we let somebody say, I don't actually have a value to start with, but I'd like you to seed a pod with this transient or transient-like thing or mutable thing, just to start with? Can I fire it up? Can I initialize it that way? would you be able to revisit pods? So the earlier slide I showed, you come in, you get a value, you do some transient stuff, you get another value, you take that out. There's another model that says, well, at any point in time, at any time you look at it, this is like Schrodinger's pod. Anytime you look at it, you get a value, but it can keep going. In other words, it might produce a value on deref and then make a new transient and then allow more operations and do that. That's very tricky. I did make something that does that, but I'm not sure it's a good idea. The other question is lifting pods up so you can do more composite operations. So the big bugbears with using locks are the composability problem, lock acquisition order, and then trying to provide multiple work that encompasses multiple units of data correctly, right? So you always have these problems when you use systems with locks. It's like, I need to manipulate X, Y, and Z. What locks do I need to acquire in order to do that? It's very challenging. It usually ends up on written on napkins or something like that, or Joe knows how that works. So there's a notion of pod groups where you could actually say, inside this set of pods, do this work. And that would do the lock acquisition order part, which would mean that you could safely manipulate more than one thing. This goes way beyond synchronized. And what's the problem with synchronized? It makes each individual method synchronized. You can't actually build anything out of that. Right? You can make caches out of things where every operation is atomic. You can't make anything more sophisticated than caches out of that. Because you can't combine two operations. You can't say, if it's not there, make a decision and do something else, unless you've turned if it's not there into a special atomic operation. And you can't say if both these things are there, or add these three things all at once. Or, the classic problem, move this from here to there. And don't make it vanish somewhere in the middle of that. That's the things traditionally you have to use locks for, but pod groups solve that problem much more cleanly. Again, I think they take care of 2/3 of the problems with locks, and they call out and identify and catch the third. However, if you keep thinking about this, you realize that seems like a really fancy thing, the pod, but it might also do too much. The vast majority of the applications you see of things like this, and the things you would think about that would work like this, are in the sort of what I would call the building or birthing category, right? I'm going to start with something empty, I'm going to pile a bunch of stuff into it, and then I'm done. I need to give that to the world. I don't want to do that in a loop with a functional object and create a million temporary things nobody ever cared about and have the overhead of functional programming when no one could see it. And that visibility thing is really a critical thing. We don't actually care about functional programming for things we can't see, right? Except for the complexity it gives us in trying to understand how they work, which is why you still want models like this. So if you were just thinking about building or birthing, you could have a much simpler contract where all you say is, like add or conj or append or something like that. Just put this stuff in. And it's a one-way street. It's like you can put stuff in. It's a sink. You can put stuff in. You can't actually do anything else. While you're doing that, you can't look at it or anything else. Just pile stuff in. I think Google's Sawzall language has these accumulators. So it's very functional, but all these things need outputs, and so they just pour them into something that they can't actually talk to again. And the beautiful thing about something like this, which let's just call an accumulator for the moment, is that same front end, you could put on some pod-like transient builder thingy, but you could put it also on queues and a bunch of other things. You could sort of have a more generic construct, which is just about putting stuff someplace. And I think that's potentially interesting. And maybe even if you decide to do pods, you want to make this notion first class, make it the front end of a pod, or the entry point to pod change. Okay, last topic before we go and start talking. So we did talk about Extensible Reader, starting with dates last week, and I thought it would be a great opportunity to sort of talk, which is a little bit more efficient, about what the idea here is. And we already had somebody say, Clojure data is much better than JSON. And that's an easy thing to say, but it's an important thing to think about. Why do we think that is? And is it the greatest thing ever? yet. I agree it's better, but when we saw the enumeration, what was on the enumeration slide? First of all, whose slide was that? The JSON slide? Yeah. So what was on the slide? You can't answer. More data types, right? So what would be the advantages of Clojure data over JSON? More data types, what else? Metadata. Those things are pretty awesome. But when you think about what are some other examples of serialization formats? So maybe we beat JSON already there. What else have we got? XML. Let's not even compare XML to Clojure data. What does XML have over JSON? That's one thing. What else? X. XML has X. Actually, XML has X and we don't have X. That's not good. So what happens? What happens when we want something we don't have? Right now in Clojure data, when we want to talk about a date, what do? All kinds of stuff that's not a date, right? And while you can build two ends of a system that do that, you lose something really critical. So I'll ask another question. What's the difference between JSON, XML, and Clojure data and protocol buffers? That's one. Yeah. The first set is self-describing. What's the other set? If you send me some protocol buffer data, what can I do with it?
Save it somewhere.
Dev null, I don't know. I mean, there's not a lot useful I could do with it. I could save it for you till later and give it back to you intact, maybe. So that's a big thing, right? Having a self-describing data structure. What does that mean for someone when you have a self-describing data structure? It means you can send me stuff I don't really understand. I can actually do a significant amount with it, right? Because if you send me strings that have dates in it and some other strings have URIs in them and some other strings have some other random stuff in them and some numbers mean numbers and some numbers mean dates, what have I now got? I have something I need to understand the schema of in order to correctly process, render, allow the user to edit. If you sent me something, some hybrid data structure, and it had dates in it, and I didn't really know what the bigger picture was, could I give the user an editor for that? Oh my God. No, actually, I could not really. The answer is no, you couldn't. So you have to be very careful, right? When you say, I could just use a string, you could just use a string, but when you do, you're moving away from self-description. And self-description is really valuable. So I do think it's great that we have more types, and I think some people want even more still. And certainly we're using more types than we can represent. How many people are using Clojure data to represent things it doesn't represent at the bottom? Like dates or URIs or something else. So it happens. And we'd like to do more of that. So I think we want to get the X in there. The trick is, we need to think broadly about how to do that. In particular, I think I should start looking at either more data types that are kind of well known, like date, or real true extensibility, like user stuff. You end up having this bifurcation between the serialization transport format and the semantics that are conveyed there and the representational space. Like already we had this fantastic, very highly predictable disagreement about what kind of date do we want to get, because there's no right answer, right? Different programs have different needs, different requirements. It's completely correct to say they need to use different kinds of dates. On the other hand, being extensible can't mean Clojure is going to start making first-class libraries for every type of thing everybody might want to possibly use. That's going to create a tremendous amount of wheel rebuilding, especially in areas where there are good libraries. So that's sort of the why. The idea that I'm floating right now is that we separate the print-read representation and semantics from the programmatic representation, right? Stuart showed us sharp equals the other day. He's getting kicked out of sharp equals club, by the way, as a result. What's wrong with using sharp equals for this? Why can't I say sharp equals date blah thing? That'll work, right? It'll give me exactly what I want, right? Is it actually now self-describing? Only to what? Clojure, a Clojure app maybe. What if I sent that to Clojure script? A Java constructor call. No. So we can't do this. We need to split these things up. This is what design is. Design is take your good idea, find how many pieces you can cut it up into, because it'll be better when you're done. So we have to split these things up. The print-read representation and the semantics of that from the programmatic representation. So one way to do that, and it's sort of like, if you can do this well once, you're completely out of jail because you've built an extensible system that is composable, is to just say, we'll have some way to say, I'm giving you something extensible, and I'm using that to tag something you already know how to read. That's it. How many people are familiar with Erlang's the transport format? What's it called? No, the binary term thing. BRT. ERT, right. And then somebody made BERT. Who made BERT? BERT is the text version of that, right? Yeah, that the Reddit guys made? Who? GitHub. Somebody cooler than me made it. But the idea behind, in the Erlang implementation is really sound. It basically says, we only have, however many types there are in Erlang, 6 or something. But we want to convey information about different semantics. All we're going to let you do is say, use a map in this way, and that tag will label this other data structure we already know how to represent as being that thing. And this is the same kind of idea. We have a tag on something that's readable, and we use that to do these first 2 jobs, right? What are the semantics? The tag dictates what that is. We say instant means a point in time, and all agree on that, and how we're going to print it. And then the type you get can be independent, as long as the representation you use is something we can already read. You can't say, I'm going to put these weird characters in here. So this is not what people expect from extensible readers. They expect, I want to make, I don't know what characters do we have left? $, do this thing. I want $sign to be some magical. We're not talking about that at all now. We're saying we're not actually going to give you more than one last thing. The last thing is a portal to extensibility, and then you'd be able to leverage anything we already read, including any extensions that have already been made. So this is what that looks like. You could, for instance, say, instead of saying sharp @, as cool as that is, sharp instant, and don't get all fixated on the actual syntax here. This is just the idea. Tag readable thing. By saying tag readable thing, and where the readable thing is the string with a date, you're saying this thing, once you've read it, should be passed to something that expects to get a string. We all agreed we're going to use a string with this parse format for this purpose. And then the value they're going to get, the actual type of thing they get back, would be something they could plug in. They could register and say, when I read instance in this program, I want to get Joda instant type. And as long as they made a construct, provided a plug from this string format to Joda instant type, that's what they would get, and the reader would allow that. But could I send this to JavaScript and have something meaningful happen? Sure. Could I send it to anybody? Sure. If we had this, would we have our X? Yeah. This is the end game, right? So the next one might be create an array of ints. And the last variant here would be the user extension point, right? I don't know what kind of composite thing you might want to have. Because we have namespaces, we can just use namespace tags. So we'll say non-namespace tags are reserved for the language, or things, which will include things we all agree everybody needs. But if you need something else, you can now say this. And the beautiful thing about this is you're not actually saying, I'm calling some specific constructor or anything like that. You now have a way to talk about semantically, I want to send my foos around, And I can build one end which produces foods in Clojure, another end which consumes foods in Clojure script, and another end that sends them through some event processing system which is completely, hopefully, language independent. And this is a good recipe for that. I would love we have, Neil talked about all the ways to grassroot up. I'd love for Clojure data as a serialization format to be one of the roots, because it really does kick butt. And with something like this, I think it's now plainly superior to the other options. So that's the general idea there. And now it's time for questions.
Can I just make the point, if someone want to go with the Extensible Reader thing, the tag format is exactly what YAML uses for extensibility.
Okay.
So if you want to see how that's implemented and how people do it, you basically reinvented exactly that.
Yeah, I mean, I'm not claiming any novelty here. I'm ripping it off from Erlang, but I'm sure they might have to. Yes, here.
So print2 currently, like, it spits out classes and creates
Yes.
and the tags replace it? Is that kind of...
Well, so there's a different reason for, print2 is used for a bunch of different reasons. If for some reason you super care, so semantically, there's no difference between array map and hash map, persistent hash map and persistent array map. So if it would only be that you somehow care that you'd be using print2 for that. The other real reason for having print2 is like for things like, well, no, actually you don't need it for strings even. Yeah, that's basically the thing, that where there's some polymorphic nature to what you're supplying, and you don't want to have it erased by the round tripping. I think print2 is inherently a non-portable concept. But certainly any use of print2, and so also people use print2 because they want something like more concise for the human interactions, and something really, they need something really verbose to construct it otherwise. Yeah, this is definitely better than that, and it's way better than sharp equals. I mean, sharp equals is strictly a known stopgap thing, and there's a reason why it's a secret. It's a really great secret at this point. Should we? Go back one slide. I can do that. When is the agreement about what goes in and what comes out? Well, there's not an agreement about what goes in and what comes out. There's an agreement about what instant means and what data structure will be used to represent instance. Like there's nothing else about this. So you're asking when will the plugging happen? There's no agreement about that. We haven't decided yet what those mechanisms would be. We do want something that you can definitely insert at the bottom of everything so that you can start a program and have your preferred date be used everywhere, including dates and instance you've embedded inside programs. So even code that's being reloaded will use the same mechanism to rehydrate using the data structure of your choice. But it's really, really critical to not dictate the data structures as soon as you start, even if it's two Clojure apps in the same company. Right? You still may have disagreements about how you want to represent things, and you should be able to make an independent decision about that. I don't think we're going to support making independent decisions inside the same program, except through potentially dynamic binding, but I think we got off on the wrong track because people saw that and presumed that would be the only way we could do things, which is definitely not the plan. Yes, in the back.
In the computer algebra area, they have the problem of two systems that need to communicate what would look like a normal equation, like a polynomial. They have completely different representations and potentially different semantics for what sign means. There is an effort called OpenMath that's been going on for about 8 to 10 years to separate syntax and semantics. And I think you might find that useful for the kind of communication protocol that you're talking about.
Yeah, definitely. I mean, that's the idea here. Other questions?
So is the idea for the extensible reader that my NSFoo just gets a stream of characters and produces something from it, or there's some data structure that you give it and we turn it out?
It's read. Okay. You get that data structure as the input to your pluggable function. Yes?
On another topic, can you elaborate on this idea of querying programs? Like,
querying
what
programs.
Does that mean without click?
What does it mean?
Yeah.
Well,
Or what would be an example, more concrete example?
There's some really simple things like how often do we use this function is a simple question. Do we ever call this function inside that function? How deeply nested are our calls to this function? Have we ever called this function while holding a lock with an open file in hand? Where is this data structure used? How is it propagated?
Like program analysis type.
Yeah, program analysis, that's right. People pay big bucks for data-like systems that analyze Java programs, and they work exactly the same way, except it's all sort of bespoke stuff. They take the output of an analysis phase and they dump it into a database, and then they give you a query engine that can access that database. It's that kind of idea. Anything you might do with aspect-oriented programming would fall into this kind of category, or any kind of cross-cutting concern. Even simple type things, right? Talking about the relationship between multiple arguments, or arguments to this function that were subsequently, the results of which were subsequently passed to that function. I mean, try talking about constraints that work like that. It's incredibly difficult, but real systems have those kind of constraints all the time. Type systems are way far away from talking about that kind of stuff.
You have been talking about conditional combination as a way
Yes.
to target different platforms. What do you think about the approach newspeak takes, which is to have communicate to the platform via interfaces or protocols, and have the environment supply the implementation for those?
I don't like that at all. That basically is reified environments, and I don't see how they could be made performant. Maybe it's my own shortcoming in thinking, but I don't. And you have to really have done that from the bottom, which Newspeak has, but I don't think it's something you can add to a language like Clojure now. We don't have first-class environments at all. Yeah.
Speaking of the conditional compilation, I was thinking that maybe this extendable reader might actually play into that, because you could add metadata via this in the compiler, because I don't know what that tag means, I just want to ignore it. And if you wanted to attach a reader macro that says, hey, I know what this extendable stuff is, it means insert this debug information here.
Well, I mean, that you could do with ordinary metadata. I don't think this really comes
Right.
into play there.
You could probably pull it out easier, as far as minifying. Well, I guess, yeah.
No, I think ordinary metadata would cover that case, but I don't think ordinary metadata covers all the cases of conditional compilation. Yes?
So pods seem to address, throwing a bunch of stuff into a collection, or into a value eventually. But one of the issues I've run into is actually needing to be able to iterate over a collection in a more performant, so a sequence, in a more performant way. And I'm wondering if there's some way we can apply, I don't know, something to do with pods there to make seats more performant.
Yeah, it depends on what you're doing. I mean, if you have access to the original data structure, there are definitely faster ways, like reduce is definitely much faster. And there's an optimized path for reduce we call internal reduce. The next thing I'd like to do in that area would be to have reducers that are able to terminate the reduction, because that's really what we're missing. If you want to do a partial iteration, that's difficult to do with reduce. Reduce basically says the whole thing. But as soon as you have a partial reduce, then what you do is you basically hand off the job of doing the work to something that knows the internals of the data structure, which does it efficiently without creating seeks, and gives you the answer back. That's ultimately the answer. Higher level things like Haskell does this amazing stuff with stream fusion. I actually think it's a good example of something for which type systems really help you, and we would struggle trying to emulate. What else? Yeah.
In the previous talks, do talk about striving for platform power. You've talked about things like access to save points, devless builds, etc. That all seem to be ways of getting closer to there. But what would you identify as the major, maybe largest couple of things that are standing between us and getting closer to platform?
Well, I mean, I think we have great platform power. Most of this has to do with finessing our utilization of the platform to be more efficient, not actual access. And so when you think about power, not to add to Stu's talk, but right, it's work over time. What's the worst value for time? Never. Infinite. No. The amorphous answer is no. So, like, you can't do that. And there are very few things for which that's true anymore. So I don't consider most of the strategic platform power as much as more efficient. Those things, making a leaner build doesn't really change how we're using the platform. Of course, leveraging Invoke Dynamic now that it's shipped is an example of platform power we're not leveraging yet. So we did that. That would be one. Fork join just came out. Same thing. So those two, there you go. They're already in the top. Oh, yes?
I think it was last year you talked about maybe introducing some kind of new scopes for variables. And there was an example where you might have done a computation with a resource and built up some kind of lazy structure that escapes and your resource is gone.
Yep.
Has anything happened in there? Or
yes, I've realized that's harder than I thought, and I'm not close to solving it. The fundamental problem is you have this nested composition problem, right? How can anyone know they can delimit the scope of something? So effectively what happens is you've done some lazy stuff, potentially dependent on resources. And maybe you consumed part of it, maybe you didn't, but the problem is you can't recognize what about what you have has these issues. How could you decide this is a scope that's going to cause them to go away if you return anything? Because the thing you return might be using some parts of that. You don't know exactly how all the trees interconnect. And so that's sort of one of the fundamental problems. It ends up that in the field, what ends up happening for people is they will casually use something like map on something like a connection to an IMAP server and want to return results. And actually what they really want is to return fully realized results. They actually do not want that connection left open. Whereas most of the problems come from people who do not want the lazy evaluation in the end. And so our near-term solution is actually to give you map-v, which maps into a vector, and it just does all the work, and it's not lazy. And so if you're going to read nested parts of a tree, and you really do want to give a fully realized tree, you'll just do that instead of something lazy. For the bigger problem, I think there's no library-style answer, but this answer is going to be different in different places. But I'm happy for somebody to think of something that I haven't. Anything else?
Yeah, when you say that platform protocols are too slow, wouldn't the JIT save us there? Just-in-time compiler, wouldn't it save us?
When I say which stuff?
When you say platform integration protocols instead of conditional completion is too slow, wouldn't the just-in-time compiler save us from the slowdown? Yeah.
We don't have reified environments. You have to add them.
Right. Yeah.
And then so how do you get them around?
Yeah, but Newspeak basically adds them via build tools.
By what?
Via build tools.
I didn't catch those.
Build tools like Linear or
Build tools. Yeah, but they're still a reified part of the execution environment, right?
Yeah, kind of.
Yeah, kind of, definitely.
Yes, there's a concept in the language, but it's not really like you can take an environment and pass it around in the language.
No, but it's happening in the runtime on your behalf. We're not, Clojure was decided way, way, way back that it was not going to have an extra argument to every function, which is going to be extra stuff for me to use for stuff like that. So we don't have that. And we call through things we don't control. It's very difficult to do that without a bottom-up kind of support for it. Maybe there's some hybrid in between what you're saying. And maybe I don't understand Newspeak well enough, but that was my understanding of it.
Yeah, probably we could just compile it when deciding which platform to target for a specific use, and just compile it there. Yeah, but I don't know either.
I don't know. You could prototype it. See? I'm not going to.
Does the hashtag hence vector type thing become the new way of writing the two-array event for all those interrupt forms?
Wow, I would hope so.
not constants, not for everything.
That depends, right? That depends on whether or not it's something the compiler has decided to also understand. It's a compiler. It's an orthogonal question whether or not the compiler will understand how it is. If the compiler does, they actually allow you to say something else in code.
Actually, along those lines, when you apply this, you're going to apply a hook to say, I want some kind of other persistent map implementation on the built-in types?
No, because we're not going to add this tag to it.
No, but I'm saying is if the reader now becomes extensible, says, if I recall, you said you're going to register, it says the tag instant gets this kind of construct, here's the thing.
Right, you have to fabricate magic special tags for the things it already knows about.
But as well, I don't know, I was just thinking if the reader was allowing you to register constructors for various types, would it be worthwhile or not worthwhile to add, you already got the hook there, say, we have a constructor now for our standard map or our standard,
Have you got better maps that are not shared?
I don't know. Well, where I'm going with, you're talking about using...
The answer to your question is yes, I'm just...
No, well, you're talking about using this as a serialization, like just for example, you may want to pull it in and have it if Java pulls it in, it may want it to be, heaven forbid, immutable, right? But you can just use it that way and say, just suck in that data structure and give me mutable hash maps whenever you see a map.
In the binding context, I could see something like that, potentially. Yeah. But we don't want to change the maps to be more ornate.
No, that's not what I was saying.
Well, so that means you'd have to have a magic hook for the things that it already knows about, which don't have tags.
Correct, right. But it's just built in with the
It would definitely be possible. You make everything big now.
There's a lot of interest in gradual typing, soft typing, to try to bridge that gap between static and dynamic typing.
I think that's what I'm talking about with queryable programs. And I think that's exactly what that is. But I wouldn't want to limit your imagination to what type systems do. That's all. I think that's exactly what I'm talking about when I'm talking about that. Because that's what that is, right? You take a program, doesn't necessarily indicate much. I would like to be able to say, you didn't bother to annotate your types, but I could for you over the logic side. Why not? You let the lazy guys do what they want to do, and then the scrupulous guys can do what they want to do. Why they don't that way. I wouldn't call them that. But. Yeah.
For Clojure data, would you consider a binary including like ASN.1 or automatically inserting some metadata, allowing you to skip unwanted data in constant time?
Don't know about that. That's very, I understand completely what you're asking for there. It may be the case that certain tags would have that characteristic, right? In other words, they'd have a way, like you would say, if it's a really huge thing, part of the agreed upon format would be that there's a count at the front of it. It makes it skippable. But making a full skippable thing that supports nesting, so the trick is usually nesting and things like that. Have you ever looked at like chunk file formats and some things like that, that gets much more involved, right? Because you want to be able to say, depending on which level I'm at, I want to skip the entire set of different things to get over to the next thing. And as soon as you expand your scope beyond one datum, right, or one structure to a composite thing that requires a set of these things or a nested set of these things, then the skipping job becomes much more difficult, right? You can always get down to say, I'm just going to skip one thing. You only have the ability to skip one thing. Usually that's insufficient in the end. But it would be a starting point. You certainly could say, there are really large things I'm going to require they be lane prefixed. Yes?
Seek is now kind of the basic list abstraction that we use in the language, right?
Yeah.
And now Phil Bagwell showed us that we may be able to use those extensible array structures, persistent structures, as implementations for lists.
Yes. should definitely consider that. I mean, the beautiful thing is there are all those abstractions between us and the representations. So, yeah. Yes?
One of the challenges that other serialization systems have run into is versioning, right? You have two different versions of your software, and one of them encoded the date one way, and one did it very slightly differently. Have you thought about how you might include versioning in this?
Yeah, you can never change your mind. For your own types, you can do whatever you like. For the agreed upon types, no, I think it's going to be one of these. We'll have to think carefully about it because we'll have to live with it. Of course, we have metadata, so to the extent the representation part you used was a type that accepted metadata, which strings don't, but like this instant, that would be a possible path for that kind of annotation. Otherwise, no. Are you talking about like a global level, on the file level?
I'm talking about, let's say that you had MyNS food, and you had a bunch of code out there that stored a bunch of that data somewhere moving across systems. Now you push out a new version of MyNS food that changes the meaning of bar, but you still want to be able to read the old version when it comes in and sort of upgrade it to the current version and keep going. Protobus does something like this, and so do some other systems. And it's built in, it's baked in. You simply say, oh no, my version of foo is foo.1. And you can stick it to the name, but I think something deeper would be nice.
Well, I mean, is there a reason why metadata doesn't work for this?
Not necessarily.
Okay. I would try that first. I mean, that's the cool thing about metadata. I mean, it ends up being so useful to have because things like this that would have been hard. We forgot to put a slot in for versions. Okay, well, slap some metadata on there, and now you have a slot. As many slots as you want. You can call them whatever you want. All right, well, I want to thank everyone again, both for using Clojure and for coming, and I hope you're having a good time and continue to do so.